Welcome to Programming for Fun with Scratch. My name is Deeth. I'm a digital services technician at the Richmond Public Library. And this is episode 11, where we're going to do some geometric animation with the pen extension. So I'm glad you could join us. So this will be my first episode without the green screen because we're reopening the library and I don't have access to that room right now. So excuse the mess behind me, please, and let's get on with looking at what we can do with the pen. So let's see, there we go. All right, I'm gonna switch over to the browser here. I think you can see everything. I had to set everything up on a new computer, so please bear with me if I take a little bit. I'm going to start a new project. If you are not logged into Scratch, I do recommend it. You can see how in the first video in this series. That way it saves all of your work online. You can access it from any computer, and it always keeps a backup and saves your work so you don't lose anything. So here we are. I've got an untitled document. I'm going to say geometric animation. And later I will go through and add the project page information. You don't need to watch while I do that, but I'll just talk about the series and add a link to our YouTube for now. Oops. Okay. So we're basically just going to use one sprite for this project, I think. And let me just change the background because I like it. I like drawing on a dark background for this. We'll go to backdrops, choose the paint, just make it black, and I need to convert to bitmap for the bucket to work. Not sure why they give you a bucket icon if it doesn't work, but there you go. All right, and for the sprite, we can keep it the cat or we can make it something else. It doesn't really matter because the first thing we're going to do in our code is hide it. We could show the mouse as it's drawing, show the sprite as it's drawing everything, but we're going to be trying to draw as fast as we can, so it really doesn't help much. So the first thing, let's see, what do we need? Anytime we're getting started on a new project, the first thing is the when green flag clicked. And that would be looks. We're going to, we're still, never mind. We are still in the backdrop. Let me change over to the sprite. Do that again. Events, when green flag clicked. And hide. All right. Now the sprite is gone, but we can still see what it draws. Now the drawing operations in this version of Scratch were moved to an extension. So let's pull that up. So click in the lower left corner to bring up the extensions in case I did that too fast. So we're just going down here to that lower left corner. And actually, yeah, I think you can see that. And clicking on the blue icon there, and that will bring up our extensions. And what we want right now is the pen. And that gives us all of these features, all these new blocks. And I think one of the first things we'll do when we start, when we click on the green flag, is we'll erase everything we drew last time, so we can start over. We're going to be using several of these blocks a lot, but let's see what we actually want to do here. I think the pen is down by default. Right now it's orange. So now if we use motion blocks, if we just say move and turn and move, for instance, then we should see, maybe if we move more. see an orange line. Maybe we do need to say pen down first. Easy enough to try and find out. That's what I love about Scratch. One of the things is it's just so easy to experiment and to try different things. Let's always start in the center. We may be by now off the map. Go to 0, 0, negative 0, negative 0. It's going to be the same. Okay, there we go. Now it's drawing blue. So I was expecting orange because that's what the block has there. Let's go ahead and set that color to a default that we want. There we go. Now we didn't set the angle back. We set ourself back to 0, 0. I'm going to take those minus signs off just because they bother me. Okay, but we didn't change our angle back to default. So we're rotating a little bit, 15 degrees when we do this. And so every time we do this again, we're going to keep rotating. For some things, we may want to keep that. For what we're doing right now, I think we want to just set everything back to a known default value. So we will point in a direction. And now, okay, same color. So we're just clearing the screen, drawing that same line over and over. Okay, so that's great. We can draw. Don't know if we want to keep that default color. I think we're going to be changing, kind of going through the rainbow as we go. But let's just first work on drawing a shape. Now, what do we need? So I'm going to draw right now regular polyhedrons. So that's equilateral triangle is the first of the regular polyhedrons, then a square, then a pentagon, and a hexagon, etc. So what do we need to know to draw one of these? We need to know how many sides there are, how long the sides are. We could choose what color to make it. Maybe that would be useful. We could choose what rotation to put it at, although we can also get the rotation just from the sprite itself. So maybe we don't need that. What else could we need? Position, which we'll also get from the sprite. I think that might be all. Let's try that and see. Let's make a custom block that lets us draw a general geometric shape, a regular polygon that is centered on the current sprite position. So we're going to have to remember what that position is so we can go back to it. And then we're going to need a new block. And so we'll say Polygon. That's what it is. We need to know how many sides and how the length of each side. Maybe that's enough for now. Let's try just that. We can always go back and extend it if we need to, or make another block. All right, so we want to define a polygon. And what are we going to need? We're going to need an angle to turn. And the angle is going to be 360, which is all the distance in a circle divided by the number of sides. And we're also going to need to remember where we started. And maybe what angle we started at. That could be useful. I'm not sure if we'll end up pointing in the same direction at the end. I don't think we will, actually. So let's do that. So we need some variables. So we need starting x, or original X or something like that. It's for this sprite only. Starting Y and starting angle or direction. Direction is the angle that we're facing at any given time. And then one more, which is we're going to set a temporary value here of the angle to turn for each side. We'll just make that angle. So we use direction for which way we're facing. Hopefully that won't be confusing. We might come back and change it. We'll see. We don't need these to be visible. We can do that if we're debugging and having any problems. All right. So we need to set these variables. So we're going to we've got 4 variables. And so set angle to, what's our current, no, so angle is 360 divided by sides, right? So we need a division operator. Okay. And we haven't done a lot with creating, I don't know, maybe we have, creating blocks that take arguments like this. So that's good. This is a good example to see that. We need to set our angle. Oops. Set our angle to oh, no, not our angle. So direction, starting X, starting Y. I was confusing myself because they all said angle. All right, so these are all taken from our X position, our direction, and our Y position. And the reason we can't just use these later is we're going to actually be moving the sprite around to draw the shape, and then we want to be able to go back to those. And so we'll actually, at the end, set, let's see, go to XY, and point and direction, and those will come from our variables. So point and direction, starting direction, and starting X, oops, starting Y. So this will be the end of our block here, just to make sure we are back in a known position. So if we're moving the sprite and then we want to draw a shape, we want to end up with the sprite back where it was before the shape, and then we can continue moving the sprite. That's going to be useful later. All right, so now we actually have to do the drawing. 2 things we need to do here is we're going to say pen up before we start moving around. Pen up. We're going to do pen up here because when we move to these positions, we don't want to draw. All right, so let's see, pen up, and then where do we need to move to? So we need to move to the outer part where we're going to do the shape. And I know that a hexagon, it would be the same as the length of the sides, but I don't think that's true of all the shapes. So how do we determine how far to move? So if we just moved length, that would not work. Huh. So we're gonna have to do some math here, and I'm not sure what the math is. Let's try. Let's just try length and see what happens, and then we can make adjustments. I think we'll probably end up looking this up on the web. Okay, I'm back. I found the information I needed, but it was a website that had a lot of ads, so I have cut that part out. And I'm going to just show you what I came up with. So instead of watching me flail around for a while, trying to figure out the math for this. Okay, so we need to calculate the radius to the vertex, the points of the polygon, and I've got a block I created for that. So we're going to set the radius. I went over and created a radius variable and a couple others that we'll get to. All right, so we set the radius to. All right, I'm going to work from the inside out. So 180, which is half of a circle, so turning all basically, so half of a circle divided by the number of sides. So that's the same as taking a circle divided by the number of sides and dividing by 2. So 180 divided by the number of sides. We take the sine of that. Now sine gives you a measurement around a circle, and often sine is given in terms of radians, which 2 pi radians is a complete circle. But Scratch works in degrees, so 360 radians would describe a complete circle. And then we take the result of taking sine of this, multiply it by 2, and then divide the length by that. Now sine is going to give us a number between -1 and 1. So this now goes between -2 and 2. And we're multiplying by the length by that to get the radius. I think because we are dividing this by 2, we're not going to go negative. So this should always be a positive number. And so now we get this, now gives us the radius. So we're not going around the circle, we're finding a specific point on a circle and finding the length of that. The length from the center of our polygon to that. And so then we save that as radius. We're going to do pen up now, so that we're not drawing, and moved the pen down over here so we're not drawing a line when we start. Now we need what's in between these two pen ups, where we actually do pen down and draw. So now that we have a radius, we need to move to it. So let's go over here, and we will move radius. That will take us to the edge of our polygon from the center. Now we're still facing exactly outside of the polygon. So if there's a vertex here, we want to turn almost completely around and then draw the side. So what this does, this also took a bit of looking at math sites. 180 turns us completely around. 180 minus the angle divided by 2 is how much less than all the way around we want to go. So 180 minus angle divided by 2 will put us facing the right direction to start drawing the edge of the polygon. So now we need a loop. So we can go over here. We want to repeat. How many times do we want to repeat? Once for each of the number of sides. And so here we will turn, and I don't remember which way we need to turn. We'll play around with it and move. Or actually move and then turn, because we've already turned for the first one. So we're going to move length. That's easy. And turn angle. So we already calculated the angle. And let's just try that and see. What's happening? Oh, we're not actually drawing a polygon. So let's try drawing a triangle. So 3 sides, 100. Still nothing. What am I missing? Pen. Oh, I need to say pen down. Right, I mentioned that and then I didn't do it. All right, so we're moving still and turning. So at this point, we pin down. Hey, not only do we have a triangle, but it's pointing the direction that our sprite is pointing, because by default our sprite is always pointing 90 degrees to the right. It's consistent. Now, the big question is, if we make more of them, so here I'm just right-clicking on a block and clicking duplicate from the pop-up menu. If we make more of them and say make them a little bigger each time, do they nest properly? Like they should all be centered exactly on that 0, 0 spot where the sprite is. So let's try that. Hey, look at that. Nice and neatly nested. Beautiful. So that's the part that I went off and figured these 2 bits for, especially getting this 180 minus 180 minus angle. That part actually took some trial and error to get right so that they are all perfectly aligned. And you can see if we change the numbers here, each polygon is always centered at the center of the sprite. And because we always move over here, we move back to the center where we started from, or not to the center, but to the position we started from. We always end up with them correctly sized there. So nice, that worked. And now we can start doing some more interesting things with them. So one of those things is let's change the color. So let's just go over here and let's actually make a loop so that we can do things over and over. We'll loop forever, just like a game. And whatever we do in here. So this is just drawing them over and over in the same spot, so they look a little darker because we're drawing again and again. But so let's say, where do we have color? It's under pen. So change pen color by, let's just say 1 for now. Doesn't go too fast. And now they'll slowly cycle through the rainbow. We could what do we want here? I'm looking for another block, so we could repeat 100, and let's say, do I have a size block, size variable? Angle, frames, radius. Let's rename that to size. We set size to 30, and change size by 1, and then here we can just say let's make that a hexagon, and then just make that size. You can probably see what I'm doing here. We're going to make a little, like a tunnel effect. Now that's interesting. Why? Oh, sides, 6 sides, size. Oh, that changes the angle. Right. There we go. Okay, it messes up when it gets too big. Let's make that 50. It's also kind of slow. And I'll put that in there. So one of the things we can do to make it faster is if we right-click on our block definition, click Edit. Oh no, I have it run without screen refresh. Okay, run without screen refresh will make this much, much faster than it would be otherwise. Okay, now we got a little rainbow effect. That's pretty quick. If you want it even faster, it's still getting a little too big. Going from 30 and repeating. Oh, right. I never go back to 30 again. So we want that to be here. There we go. So now we can repeat 100. If we want it to go really fast, we can go up here to the edit menu and turn on turbo mode. And now we've got this cool strobing effect. Yeah. That's going to get annoying pretty quick, so let's stop that. I turn off turbo mode. I don't think we need it for most of this. And I'm going to keep repeat forever and have oh yeah, it's under motion. Move, go to mouse button. All right, and then we will also change pen color in our forever loop, and we'll draw a polygon. Yeah, let's just try that for now. Oh, 6. We don't have size set, so we'll just make it 50 for now. And now we can have this like rainbow drawing tool as we go along. So let's make another block to rotate, to cycle through our polygon sizes. Cycle poly, and all this does is, let's see, I created a variable I think called sides. So what we're going to do is just add one to sides. Change sides by 1, but then if, and we need controls, if sides is bigger than some number. So sides will go triangle, square, pentagon, hexagon. So hexagon would be 6 sides. We'll limit it to that for now. We can always change it later. So if we want to, so let's see. So if sensing, no, operators. If sides is greater than 6, then set sides. Now we don't want to set it to 0 because you can't have a polygon with 0 sides. The fewest you can have is 3, which is a triangle. All right, so now we have this cycle polygon block. So let's put that in an if over here. So if mouse is down, I would like to put this on a mouse click. Event, but I don't see a mouse click event. You can see when when the sprite is clicked, but that's not quite the same. All right, so when if mouse is down, cycle the polygon, and so now, now we need to use let's see, not size but sides. There. We'll do something with size in a moment. So now we can, cycle is not working. If sides is, I have it greater than 50. I wanted that to be 6. All right. There we go. Now we've got sides. I think the first time we go through here, we need to initialize sides to something. Let's set it at 6. Point and direction set sides to 6. So now we'll always start with a hexagon, but we get different things by clicking. And if you hold it, you can actually draw, and it's going to keep changing shapes every time it draws, which that can be neat too. Okay, we've got a cool effect creating this kind of pastel pattern. Let's just do one more thing with it, and then I'm going to let you play and see what you can come up with. So the next thing I want to do is make it change the size of the polygon as we're drawing. And I want to do that with the sine function, so it kind of gets smaller and bigger, like a breathing sort of thing. So we'll create a block for that. And we'll also call this cycle size. So this one, so we're going to set an initial size. Maybe 30. Now we can use size here. So that should just work. Yeah. And now we're going to cycle it. We are going to add and remove. Yeah, let's just try that. No, I'm going to make it completely dependent on the frame rate. So I have this variable frames that we're not using right now. So let's use that. I'm going to initialize it to 0 at the beginning. Frames 0. And every time we go through our loop, we're going to add 1. Okay, so we're defining the cycle size. That right, we need, what do we need? We need a sine function. A sine is nice, it goes around a circle, it gives it kind of a breathing effect because it speeds up and slows down. But sine is going to go from -1 to 1 is what it's going to return. And we don't want this size to go negative, so we're going to have to do some other math in there. We also, let's see, I think I mentioned that there was a frames counter, and we need to actually do something with that. So we set it to 0, and now we're going to, every time we go through the loop, we will, oh, I put that there, we just, not an angle, but frames. Right. Okay, so now we want size, set size to So this is going to return a number between 0 and 1. If we add 2 to it, then it'll be a number between 1 and 3. And we can do something with that. So setting up plus. So the result of sine plus 3 plus 2. And we need frames. Is what we'll take a sine of. So now we're getting a number between 1 and 3, some fractional number in there. It's going to be smoothly changing in between them. And the next thing we need is to multiply that and in it yeah, so that's nice. We won't go below the multiple number. So if we multiply it by 30, it will go between 30 and 90. If we multiply by, if we set it to 10, for instance, it'll be between 10 and 30. Whoop. No. There we go. Let's try that. And now we just need to call cycle size. We'll do that here. So now we're cycling colors, we're cycling size. We can cycle a polygon by clicking on it. And you can see, let's see, is it really changing though? I don't see the size change. Oh, because we have to use size. No, we are. Polygon of size. So we're setting it, oh, we're setting angle. Duh. Okay, let's try that again. There we go. Gets smaller. And then it gets bigger. Yeah, it's kind of changing pretty slow. We could multiply frames to speed it up, but that's all right. So now we get some interesting texture from the changing of the size, the changing of the shape. If we stay in one place, we get a little tunnel. And yeah, I think that is basically all I wanted to do. If you, for instance, let's see, one more thing. If you wanted to take all this away for now. If you wanted to just rotate, so we're moving right now with the mouse, but if you just wanted to rotate the shape, so if you had a triangle, for instance, yeah, let's do a couple of things. For instance, you can make specific polygon blocks now very easily. So I'm going to make a triangle that takes a length of the sides, and with that I just need to call polygon with length and 3. Now I've got a triangle block. So I'm going to use that triangle block here, and forever draw a triangle about 120. Right. So there we go. Now if I want to rotate that, all I have to do is actually rotate the sprite. So it's pretty neat. And again, we can, by changing the pen color, we can kind of create the neat rainbow effects. Yeah, that's pretty cool. Let's make that a little bigger. So by changing the size, the rotation, the number of sides, the colors, connecting motion to things like, we've been doing it with the mouse. You could have it actually move and bounce around. That's a really neat effect. I like that we did it in the center too. We could actually have, we could duplicate this and have multiple sprites moving around doing different colors or nested inside each other. Like we could have them rotating in different directions or at different speeds. And that gives us a lot of different effects we can do. And I'm going to leave it there. So I will share this. I will put a link to it in the description. Please go to the link and make a copy for yourself and play around with it. See what neat effects you can get. If you come up with anything interesting, by all means, share them with me. There is a link in the description to our comment form on the website, the library website, and that will get to me. Or you can tag me in Scratch itself, the RPL Code Club account, and hope this has been fun, and I hope you learned something. It's been fun talking to you, and I hope to do this again with you in a couple of weeks. All right. Have a great day. Bye now.